Okay, welcome to part 2 of our lesson on the cross product. So you will recall from the previous video or lesson that if A and B are vectors in R3, so this only works in R3, doesn't work in R2 or any other dimensions, then the cross product will be the vector perpendicular to both A and B, following the right-hand rule. And then, you might be asking also right now, what is how do I know the magnitude? And we're going to get to magnitude sort of in the next section. But the way you're going to calculate this vector, which is equal to the cross product, is came up with the formula A2 B3 minus B2 A3 for the x value, the y value, and then the the z value was A1 minus. Okay, so we mentioned sort of that might seem difficult to remember. So here's a couple tricks people use. So sometimes what people will do is, well, okay, so first we gotta list what A is. So A is A1, A2, A3. So that's its x, y, and z components. And B is B1, B2, B3. Okay, you know what? First I'll show you what I do. Here's what I do. I say, okay, the first component that's our x component. Well, the x component comes from the y and the z, right? It comes from multiplying the y here with the z here, and then the y here with the z here. Then you subtract. And then how do you get the y, or the second component, the y component? Well, that comes from multiplying the other two. So it comes from multiplying the z with the x, and then the z here with the x here. So that's the z times the x minus the x times the z. Okay, and then the last component, which is our z component, y, and this was x. So z is going to come from multiplying the x's and the y's. So it comes from multiplying the x with the y, and then the x with the y. Okay, so you get the x from multiplying the y and the z, the y from multiplying the x and the z, and the z from multiplying the x and the y. You just have to be a little bit careful about the order you do it in to make sure you're subtracting in the right order. But I find that that's sort of, if I remember that, I remember the rule. But some people still, they get confused about what's the order you multiply it in. So they like sort of another rule. So what they'll do is they'll list all the components of A vertically, starting at A2, and then they list A2 again. And then they do the same thing with, so that's B, with the B component. And now the first component, they remember you get from multiplying sort of across. So it's this one, A2, B3, minus this one. And then the next one, you do sort of cross multiplying again. So A3, B1 minus A1, B3, and then this one. So A1, B2 minus A2, B1. So that's the x, y, and z. So it's nice. You don't have to really think about what you're doing. You just kind of have to follow the pattern there. So if that's the way you like to do it, by all means, go ahead. The important thing is basically that you know how to do it. Okay. So we'll do one example. So let's take vectors A. So 2, minus 1, 3, and B. 3, minus 1, 2. So we want to figure out A cross B. So let's write down the formula. So the formula was A2 b3 minus b2 a3, and the y component a3 b1 minus a1 b3, and then the z component a1 b2 minus a2 b1. And then how you remember that, totally up to you. And now let's work it out. So a2 is the second a component, so minus 1 times b3, that's the third b component, so 2, minus b2 is negative 1, a3 is 3. So this is going to give us our x component. Now for our y component, a3, third a component, times b1, which is 3, minus a1, which is 2, b3, which is 2 also. And then that's our y component, and now our z component will be a1, which is 2, times b2, which is minus 1, minus a2, minus 1 again, and b1, which is 3. And now just kind of multiply this all out. So minus 1 times 2, minus 2, plus 3, 9, minus 4, minus 2, plus 3. So the vector is 1, 5, 1. Okay, so this is A cross B. So it turns out this vector should be perpendicular to this vector and this vector. So actually, yeah, let's verify that, right? How do you verify that A is perpendicular to A cross B? Well, we know that two vectors are perpendicular if their dot product is equal to 0. So A is 2 minus 1, 3, and I dot that with A cross B. Then a dot product, so I multiply the x's, so 2 times 1 plus minus 1 times 5 plus 3 times 1. So 2 minus 5 plus 3 is 0. Good, they are perpendicular. We can do the same thing for B, right? We could verify that B dot A cross B is also perpendicular. So B was 3 minus 1, 2. Then if I dot that with 1, 5, 1, I should get 0. So I get 3 minus 5 plus 2. Again, perpendicular. So that we see that A cross B is indeed perpendicular to both A and B. Okay. As a good exercise, maybe it wouldn't be a bad idea to, so I won't do this, but I'll leave it to you to do. Calculate B cross A. So that should be a vector also perpendicular to A and B. So should be perpendicular to A and, no, I better write and B, but in the opposite direction of B, of A cross B. Okay. So this is a good example. Really, what you're doing here is you're practicing the cross product. You know, the biggest thing at first for this lesson will be remembering the formula. So just the more you do, the more you're gonna remember the rule. Okay. So just quickly before I end this, I'm just going to list some properties of cross product, some of which we have already mentioned. So I'm not going to verify these, although I think I kind of verified a couple of them just geometrically. The first one involves A cross B, and we said that was, it's not equal to B cross A, but it was equal to the vector in the opposite direction. So that would be the negative. You actually, that last example probably should verify that rule for you, or at least it'll show it in one case. So it's kind of interesting, right? Normally multiplication, it doesn't matter what order you multiply things, but when you're multiplying two vectors using the cross product, so order matters, right? So that's unusual for multiplication. So product is a little bit different, cross product at least. So order matters. The other, multiplication properties still do work though. So like things like our distributive property. So let's say you're multiplying P cross Q plus R in brackets, then you can distribute. This will work. So that'll be P cross R plus, or P cross Q plus P cross R. Okay, so distributive. So distributive law, I think I lost some of that, got cut off. Our third rule would be if you're multiplying by a scalar, so K times P dot Q, so K is a scalar, then you can do the scalar times P and then cross it with Q, or you can do P and cross it with the scalar times Q. So it doesn't really matter what order you do it in again. So that's consistent with our normal properties of multiplication.